Hello again, sick-twisted weather freaks. It's meteorologist DT here from weatherist.com with our this week in weather report here, and taking a look at the weather. Would have done some of these videos earlier, but it's been kind of depressing around here with what's going on in the news lately, and the number of people who simply uh, refuse to, you know, follow basic science and basic reasoning. And it's very depressing to be a person of science and critical thinking in this country right now. So I haven't done a lot of these videos, but I'll start doing more of them again, I guess. All right, so let's get right to it here. This is, of course, this is my picture of my smiling face from Richmond, Virginia. There's the Twitter page, and there's the Facebook page. Okay, well, topics here. We're obviously going to be talking about a couple of different things here. The record cold blast coming up. Obviously, it's a big deal. It's all over, weather forums everywhere, and it should be because it's very, very impressive. We'll see why. We'll talk about the frost and the freeze risk here for the next 5 days for Virginia, Maryland, North Carolina, Delaware, and West Virginia, where in some areas it seems worse than it may be. We'll get to that why in a minute. Talk about the potential for New England snowstorm, New York State snowstorm, and then the cold pattern coming to an end around May 15th, and then a warm up coming, maybe a significant warm up, and then the La Nina clearly coming on, which has implications for the summer and the hurricane season. So let's get right to it. Now, this image here is the model. This is actually the European model from April 6th. And you can see that even back in April 6th, we had a very strong blocking pattern there over north central Canada and an upper low. So we had a very strong, normally when you have, of course, an upper low over Greenland like this, you have a negative NAO. But in this case, what happened was the negative NAO, the block over north central Canada here had retrograded or moved into this position here. So it was still counted as a negative NAO. Anyway, and we had a trough on the west coast, so that was we started getting blocking and cold then, and up until that point here, if you remember March and April, we were all quite warm, the entire eastern half of the country, even the Midwest, and then with this beginning of this pattern, the pattern had collapsed, and we can see the change here, and it turned colder. So this here is the Arctic oscillation plotted back since January, and you can see that for the most part, it's been quite strongly negative. Through all of this time frame, you can see it's been very strongly negative. And then as we got into April, what's happened is that it's actually gone a couple of little waves, a little bit's gone negative a little bit here, some neutral here. So, and then it's bounced back up slightly positive. But this is very, very different from what we saw for most of the winter, where everything, up until the end of March was strongly positive, as you can see. And then here it's been very close, like, well, neutral just about. So that's a bit of a change. And then if we look at the tracings here for the North American oscillation on the Greenland block, again, very clear delineation here. Sometime around April 1st, it changed. And for the most part, we were generally positive. I mean, a little bit of neutral conditions here in February, but for the most part, we were positive. And then we had this big spike where we went negative. Now it's neutral again, and then another spike where it's dropping negative. So it's been a different type of April, and there's no doubt about that. And you can see that negative spike there, April 1st through the first week of April, right there. That's this feature right here. See, there's the block. So there you go. Okay, now in the next image, this is the PNA, which is the West Coast ridge of North America, and you can see again consistently negative for the most part. A few spikes here where it's been a little close to, it's neutral, slightly positive, but again, for the most part, negative, negative, negative. Then we have a little spike here, it's gone up a little bit, and that's helped produce a little bit of a West Coast ridge. And we can see how these teleconnections have affected the temperatures. The upper left here is the temperature anomalies for the past 30 days, and you can see the Northeast, New England down into Maryland, West Virginia, the dark green is 4 to 6 degrees Fahrenheit below normal into the blue. The Midwest, the Great Lakes as well. And in Virginia, North Carolina, 2 degrees to 4 degrees below normal. And over the last 2 weeks, since April 22nd through May 5th, again, pretty cold in New England, all the way down into portions of West Virginia, Pennsylvania. A lot of areas -4 to -6 degrees Fahrenheit. So it has been a chilly pattern because of these features here, the NAO, the Arctic oscillation, the PNA, that sort of thing. Okay, let's take a look at the pattern now. This was yesterday's model, and you can see on Tuesday that this was the low pressure area which caused the rain here. This was the upper level feature. That moves straight across. We had an upper level low here, and this is the block over Iceland, the United Kingdom. And what's going to happen is this feature is going to push in this direction. Meanwhile, look at this enormous ridge all the way up into the Arctic regions okay, pulling on the cold air. So these two features are going to like push together, and that's going to cause this feature to break off and come plunging southward, a piece of the polar vortex. And we'll see how that looks in just a second. So as a piece comes south, there it goes. Now this is here from midday here on Wednesday, and there's our upper level low right there. That was the one we just showed you. That was over the Midwest. Okay, and now here's the polar vortex being pushed southward. So there's our blocking feature. You can see it's coming westward very clearly, and we still have this enormous ridge right here from California all the way up into northern Alaska and the Arctic Circle. That's pulling on the cold air. So that feature and that feature is causing a big Arctic outbreak, and this is going to come southward. Very impressive. So let's see what that looks like. Now these are the surface maps from today, and you can see where that low pressure developed. We had the rain last night and this morning, a very decent rain here in the mid-Atlantic. One area low pressure, a couple of them consolidated into a nice coastal low, and this low is moving off the coast in that direction out to sea. But there's the next cold front coming southward. Now, the temperatures for tomorrow morning, on Thursday morning, if you're in the Shenandoah Valley, West Virginia, Western Maryland, Southwest Virginia, essentially if you're west of the Blue Ridge, your temperatures will be the low to mid 30s. And if the winds drop off tonight, you could see some scattered frost in all those areas, especially in West Virginia. But in the Shenandoah Valley, Southwest Virginia, the data has the wind staying up between 6 and 12 miles per hour tonight into tomorrow morning. And that would prevent a frost. There might be some areas of it, so I'm not that concerned. Now, in West Virginia, where the winds drop off much more rapidly, you could get a frost, a much more better chance for that happening. So that's just for tomorrow morning. Now, what happens is here comes the vortex. Boom, it drops all the way through the Great Lakes into Hudson's Bay, Canada, James Bay, Canada, and bombs out right over Montreal. Look at this monster for Saturday morning. Can you believe this? In fact, you know what I'm going to do? I'm going to enlarge this sucker off the screen so you can see it even better. Look at that. Wow. Now, again, up here we can see very clearly our features. There's a block over Greenland, and look at this enormous ridge pulling down the cold. And look at these lines come pouring out of the Arctic regions, plunging southward. That is impressive stuff. Now, if this huge monster up below was centered on the East Coast, well, everybody would have a snowstorm in the mountains of Virginia even, and then Pennsylvania, New York State, New England. But look where the upper low is. It's still over Montreal, so it's still pretty far inland. And I think that's important with the development of what's going to happen here on Friday. Now, as this system comes southward, obviously, it's going to drive a very strong cold front, and here it is on Friday. So Friday morning, Friday afternoon, here comes the cold front moving through the Ohio Valley, heavy rain, and then changing over to snow potentially in the mountains of southwestern Pennsylvania, western Maryland. And then Friday evening, as it comes through Virginia, the low pressure goes up the front right through Virginia, and then up into the coastal areas, New Jersey and New England, and it potentially could turn over to snow in the mountains of West Virginia and western Maryland and southwestern Pennsylvania. Again, high elevations here, maybe. I think the GFS is overdoing the cold here a little bit. The European is not that snowy in West Virginia. We'll get to that in a second. Now, when this front blows on through, the cold air comes pouring southward. Let's look at these temperatures for Saturday morning. The GFS is on your left, the European is on the right. Now, clearly you can see the GFS has gone freaking bonkers with the cold air. I mean, teens in the northeast portions of West Virginia, 23 degrees in Monterey and Staunton, 24 down in Blacksburg and Whitesville and all these different Hillsville, very, very cold temperatures in the southwest Virginia. If you look at the European on the right-hand side here, yeah, it's below 30 degrees throughout all the Shenandoah Valley, but it's not nearly as cold. And there's a big difference. So you notice that it even has 30 degrees as far east as almost Fredericksburg, Lake Anna, Farmville, Lynchburg, below 30 degrees. If you look at the European, say several degrees warmer. So that's a big difference. Now, if you saw temperatures that cold and you're growing fruit, if you're growing vineyard, you've already been hit by a couple of frosts in the Commonwealth and in northwest North Carolina and in central and western Maryland and in West Virginia. You don't need to see this. This is bad news. But as cold as it is, again, I think the GFS is overdone, so let's favor the European here on the right-hand side. Let's look at the conditions. Saturday morning, look at these winds. This is the GFS now, and you can see the winds are very strong. So these winds, the models are for early Saturday morning are 10, 15, 16 miles an hour out of the northwest for all of the Commonwealth and for Maryland and for western Maryland and a good portion of West Virginia. So this is too strong a wind. The wind is just too active to prevent a frost. So you can even be 27, 28, 29 degrees. If you have a northwest wind at 10, 15 miles an hour all night, you will not get a frost. Now, it's possible that might change, but that's what it looks like. So even though the temperatures could be really cold Saturday, and the cold itself might do some damage to fruits and to vineyards and what have you, to other budding agriculture stuff coming up from the ground. The wind is going to keep the frost from being a big problem here. Now, what I am concerned about is Sunday morning. So let's take a look at that. Now, this here is Sunday morning. And you can see the high at this point is now right over eastern Tennessee, southwest Virginia. The winds have dropped off completely. So, with no clouds and no wind, radiational cooling, the models are showing a much better chance for a frost here. Again, GFS on the left-hand side, European on the right-hand side. Now, the GFS is a little colder in southwest Virginia, from Roanoke all the way down into Bristol and then into northwest North Carolina. It's a little colder here than the European, but even the European has potential frost into the Virginia Piedmont. So I think this is my main concern here. Hopefully it's the European models correct with these temperatures, that the GFS is still a little on the cold side. But I think these winds will drop off. That's what I'm concerned about Sunday morning. That's the one to watch out for May 10th. Okay. Now let's talk about the snowstorm. Again, we talked about how the front's going to come through here, and then the low is going to track up the front. So let's see what happens here. Now this is the GFS for midday. There's the low over central Virginia, close to just to the west of Fredericksburg, I think. And again, notice it's got snow in the mountains of West Virginia. I think that's overdoing it, but it's not out of the question. And then it goes up along the coast. Look where the low is here on the bottom right-hand side. Let me highlight this so you can see what I'm talking about. So there is the low in Virginia. Okay, this is a Friday night, and then this here is early Saturday morning around 2 a.m. See where the low is? South and east. Now, that's an off-the-coast position, so that supports a colder temperatures. And in the hills of northwest Connecticut and western Massachusetts and maybe northwest Jersey, maybe the Poconos, it goes over to snow. Look at the north winds pulling down the cold air. Very impressive. Now, in terms of what the models actually show for snowfall amounts, this is the GFS, the 12Z run. Again, notice it's all elevation. You got some snow in the mountains of northwest Connecticut, western Massachusetts, not a lot. And again, this is assuming 10-to-1 ratio. That might not be 10-to-1 ratio. In fact, I'm sure it's not going to be. And then you can see also, a couple of inches in the mountains of New York, northeast Pennsylvania, spring snow. And then notice it has a couple of inches in western Maryland and eastern portions of West Virginia. Not out of the question, especially above 1,000 feet. Now, the European, he's a little different here. Notice, remember how the maps here, this is the GFS going through Virginia, then off the coast, right? This is the European. Vastly different. The low goes north of New York City and then into central Connecticut. And as a result, all the snow is much further to the north. So, and again, there's no doubt in my mind that the European scenario is correct here and the GFS is way too far south. That being said, the European has better snow, but further inland. So Albany gets snow, Catskills gets snow, the Adirondacks get snow, and look at again northwest Massachusetts, maybe far northwest Connecticut, and then because it's pretty high up there, and then a lot of us decent snow, at least a few inches in large portions of Vermont and New Hampshire and western Maine. So all in all, this looks very reasonable here. Oh, this is all elevation snow. You can see this right along the terrain. Very nicely done there by the European model. Now, here comes the 18Z GFS, and it just screws things up big time. It's got the low off the coast. It pulls on colder air. And look at the monster, well, not monster snow, but this is a serious snowstorm on the GFS for 18Z. Just to the north and west of New York City, the Catskills, Connecticut. This is bullshit. This is way too far south and east, and it's completely ignoring the terrain. This is crap. Okay, the low here and the low here is not that far apart. And this map here, you see where it is? Let me show you. There it is here, right? Okay, that's Sunday, that's Saturday morning, 2 a.m. And then if we go here, it's almost the same position, but it's got a lot more snow. This is bullshit. No. Got to call bullshit on this one. No. Stick with the European, folks. You can't do wrong. And then again, it's also got more snow inland. So if you're on the Catskills, the Adirondacks, northern New England, you're going to get a decent spring snow out of this. Okay, now the temperatures the next 5 days, look at that for the anomalies. Holy crap. Are you kidding me? That's May? Look at these anomalies. Good googly moogly. I mean, everybody east of Mississippi, but even in the plains, very, very cold weather there. Okay, and then what happens is now going further out in time, next week, the polar vortex, which we saw coming down, call up that map again, so it was so pretty. There it is. Okay, there it is on Saturday. By Sunday, in the upper left image, there it is. And you can see it very clearly, rotating rapidly north back up into eastern Quebec, Canada. Now we have another piece of energy coming on here, and of course, we still have our monster ridge. Look at this monster from California all the way up to northwest Canada and the Arctic Circle. And there's our block in Greenland. So it's still a cold pattern because the heart of the cold air goes back up north, but you still have a monster trough here. And this is now for Tuesday, same sort of thing. A piece of energy right there. There's a blocking here, strong ridges here. But look at this. We're getting a ridge, we're getting a big trough here crashing into California, knocking down the ridge. And that's the beginning of the pattern change. So this little piece of energy over Michigan here is going to produce this little wave of low pressure on Monday night, Tuesday, rain mostly. And then you can see with the low pressure area going through, not a big deal. Now, if we look at our teleconnections here, notice a couple of things. The Arctic oscillation here is slightly negative, and then you can see it becomes neutral, right for the rest of almost for the rest of May. And then the PNA, which is positive now, goes down to neutral here. The NAO, which is negative, goes positive. So there goes our Greenland block. And the EPO stays negative right now, which supports the big ridge in Alaska. And that goes back to neutral, which means that ridge is going to go away. So there we see some changes here. Sure enough, let's take a look. See. Now here, this is 190, almost 200 hours out. May 14th and 15th. So the Europeans, the upper left, the GFS, are the bottom right. And we can see important features here. There's our vortex over eastern Canada, Greenland. Now this feature's gone, this feature here was the feature that started over here in Montreal. So it's gone up to Greenland, so that's forced the NEO to go positive. All right. And we have a big energy coming in from the west coast. And what that does is our ridge on the west coast is now only here. This is cutting underneath it. So the supply of cold air is not as strong. It only goes down to Canada and goes like that. And notice we get a ridge here. See the trough coming in? So we get a ridge forming over the eastern United States on the GFS and the European. There's our ridge. Okay. The big vortex here, which is nice, but the cold air goes back up. It's running in a west to east direction, which is a strong sign for a warming trend. Remember, we want to have the vortex coming south. We want to see a trough. That's not what we see here. It runs west to east like that. And this energy is coming in here. So, and that causes a trough here and a ridge forming there. So definitely a warming pattern. And it's still cold through the 6 to 10 day. I mean, that's at the end of the 6 to 10 day. You can see here, it's still fairly chilly. Midwest, Mid-Atlantic, we're not as cold as we are, but we're still 5 degrees, 3 degrees below normal. New England is very cold. The Great Lakes still very cold. Minnesota, Wisconsin, still 9, 10 degrees below Fahrenheit, below normal. For mid-May. And then here, this is 312 hours out, May 19th. Very clearly, you can see it now. The European has a much bigger trough here, but look at this trough on the west coast. See that? And you get a big ridge here over the Midwest and the East Coast. Now, the GFS is different. The GFS still has some ridging here, and the trough doesn't come in. So as a result, we have more northwest flow. It's a little colder, and we don't have a big ridge. So there is some difference here as to how fast the pattern is going to warm up between May on around the middle of May. I think the European's correct, but it might not be. And then next, this is May 21st. At this point now, the GFS does have the trough on the west coast, and it does have a ridge here, so we're not getting direct flow. The flow is coming down from Canada like this. It's a little bit of a trough on the East Coast, but it's not cold. And then there's our trough here. And this is the European. Look at the big trough here and a much bigger ridge here and much warmer conditions. So it does warm up. And then finally, if we look at Memorial Day weekend, we want to see what that looks like. There we go. This is, May. This is May 26th. The 5-day period covering Memorial Day. We have a bit of a block over Greenland, a bit of a trough of eastern Canada. It's not a cold pattern. It's not a warm pattern. It's about average, but it does look really wet. This sort of pattern here, we have a little bit of cold air coming southward. Okay, so that's going to drive your fronts like this. Then you have a bit of an energy to the southern jet stream, bringing in low pressure. So that's going to make for a fairly wet pattern here for Memorial Day, I think. And then last couple of points here. This here is, excuse me, go that one. This here is the new European model. The black line was the old projection. It was showing for slow cooling of ENSO region 3.4, not a La Nina until maybe after the autumn, if then. The red line is the brand new one. It just came out, and you can see it plunges a very sharp drop with La Nina by July, late June, into the heart of the hurricane season. Now, the reason why this is important is because this was the last of the big climate models that was not showing La Nina. It is showing it now. So that's a significant change. And one of the reasons why it's a significant change is because of this. This is from last week. Look at the subsurface temperatures. Look at the cold water building here. Very impressive. This is getting bigger and bigger with each week. So the La Nina is coming on. There's no doubt about that. When that cold water gets to the surface, it's going to go La Nina big time, boys and girls. And finally, that obviously has implications for the hurricane season. And the sea surface temperature maps here, you can clearly see the temperatures are quite warm across the tropical Atlantic. Now, just recently, we've had a little bit of cooling here. You can see a little bit of cooling there, but that's just, I think, just temporary. Still pretty warm water off the coast of Southwest Africa, and this all warm water, all right in here, that's, I think, is pretty significant. So I think the Atlantic Basin, for the most part, is pretty warm. As we go into May, we'll watch that carefully as we get into the closer to the season. Anyway, that's the report. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page and on the Facebook page.